Okay, great. All right, thank you, Venkatesh. So this is Ibrahim Demir. I'll be talking about the Cyberinfrastructure system for the River Morphology Information System project. And at the University of Iowa, we are managing the Cyberinfrastructure efforts with Mary and Musty and the postdocs and students. So the first step for us is to also share some of the preliminary work from our group. So at the University of Iowa, we work with many large-scale operational information systems for the state, as well as many federal organizations, including DOT, Homeland Security, DNR, and NASA, and other agencies. So these are some of the examples that we created over the last 10 years. The Iowa Water Quality Information System, Upper Mississippi Information System is another NSF project. It's actively going on right now. And one example I like to give here is the Iowa Flood Information System. Our group developed this system last 10 years ago, and it's up and running for the last 10 years. We have over 400,000 users for just the Iowa Flood Information System is supporting, mostly in Iowa and nearby states. And we are processing over 50 gigabytes of data per day just for the flooding system. So similarly, we have many other systems on water quality, groundwater, and many other water-related and disaster-related systems serving Iowa and different states. We design systems for other organizations and states as well. And we are actively managing these operational systems in our group. So hopefully we'll have a similar system with the RIMORPHIS and continue to support in the long run. So as a summary of the planned cyber activities, so we will start with the project website. It's already active on rimorphis.org. I'll talk a little bit about that in the coming slides. And then we continue with the data specification and a relational database, a data model. So we will create a detailed, a comprehensive data specification to both collect and store data and organize data in a way that will support interactive web visualizations and analysis. And we will start first with the NHT+. So we would like to create a referencing system for all the data that we connect and integrate to our system through a referencing from point all the way to watershed scale. And this is going to be our referencing background system in the data model that will support easy access to these data sets at the point level and polygon and line, as well as watershed level. And then we will continue working on data collection efforts from our partners, from both the federal and state organizations, agencies, as well as university partners. We will work with them on integrating their data to our system, both the raw data and processed data, as well as make them available through our web services, as well as visualizations and analysis components. And this will be mostly continue through the first and second year. And we will also work on a data exchange service and a programmable API, which allows us to utilize this data in our system, as well as allows other partners to integrate our data sets to their platform, to their workflows, their software, to easy consumption for their analysis and visualization needs. And then we utilize these efforts and APIs and data collection and databases and systems to connect to our web platform. So we are going to design and develop a new cyber infrastructure web platform by integrating all the data that we collect from our partners, as well as NHT+, and we will design new data exploration and visualization tools, analysis tools in our system, which will handle most of the maybe common use cases that will be handled normally by GIS or external or desktop level tools. And finally, we plan to launch a pilot, hopefully in the second year, and we will have a public launch in the third year. We organize multiple workshops in the second and third year, as well as we present this system to public and other researchers institutions through scientific conferences like AGU and many others. So you'll be able to attend some of the workshops maybe we will organize in the coming years to explain the system and capabilities and features. And here's the project website. This is going to be a live and active website we will have all the project and the workshop information as well as the project background. You will also access a resources page where we will share presentations, publications, reports, and online tools and services that we will develop throughout this project. So the resources page will be mostly active. We will make the tools and resources available as they are ready to share. And you can definitely contact us. And we will have a couple of forms here to bring community together and create some partnerships with different organizations. So we will have some partnership forms and agreements through this website as well. In terms of data organization, this is our first step. Before starting a data collection effort, we are going to plan and we are going to work on a data organization system that allows us to pinpoint data at the point scale as well as flow lines, reaches, catchments, and all the way to large-scale watershed structure in the United States. And we will create a generalized structure for these referencing system that allows us to easily connect all the data collected from partners as well as federal organizations and integrated to the system will be easily explorable through this web platform using this referencing system. And it will be based on NHT+, HR. So we will start from the catchment scale all the way down to flow lines and junctions and the reaches in the system. Everything will be connected to NHT IDs, NHT referencing, and we will also have internal IDs to define these relations between these entities and features. And we will connect our data sets, the data that we collect from our partners to this referencing system, which allows us to easily find the relevant resources, relevant features and data sets within any geographic unit. So you'll be able to use a web-based map environment to find the data based on multiple layers of queries around an area, a line, a point in different geographic units. And it's just a quick maybe example of a specification. We are just starting to define all these features and entities based on mostly NHT+, NHT+ IDs, and we are defining and collecting only information that's more relevant to organize the data. So we don't want to replicate a lot of data available through federal services. We are just mostly focusing on metadata at this level to just define the referencing and define how we can connect these real and raw data sets that how we can connect them in the geospatial environment. So it could support from HUC 2 to HUC 10 or 12, and we have all the catchments and flow lines and junctions. Everything will be defined and connected based on NHT referencing. And we'll hopefully update as the NHT changes, or if we can also allow community level maybe referencing modification as users will provide input on issues and challenges in the referencing system as well. And then we will focus on other relevant units and features like flow lines and junctions, and continue with the NHT+. But in terms of the geographic definitions of these units and features, we will use mostly static files like JSON files to define the geometries. Still, it will be available for us to do some secondary analysis on the fly, but we don't need to focus a lot on the data, but we have focused mostly on the metadata and the reorganization of these data sets to just allow us to connect all these disparate data sources together. And it's just a quick example, since it's a pilot implementation in the first phase with the NSF Geoinformatics program, we are going to focus on select a number of watersheds and regions in the US, and focusing on region 7 and region 5 with Ohio and Upper Mississippi watersheds. We will choose a significantly large area to demonstrate the capabilities and the scaling and performance of our pilot system. And as you can see from these numbers, even just in these two regions, we have over 3 million catchments and over close to 3 million flow lines and 3 million junctions just in these two regions. So the system will be a generalized environment, so it will support entire US as well as even a global scale with the referencing, with the data integration and APIs. but as a pilot, we just select a couple of watersheds just to start the pilot and demonstration. But we are happy to work with our partners to learn more about their interests and define maybe some pilots in different areas as well. So we are looking for your feedback both on the referencing system and the specification, data specification, as well as the regions. So we will share all the comprehensive data object models as well as the specification through GitHub and other open source systems. So you'll be able to see and provide feedback, and we will design this specification through with the community feedback as well. In terms of data and tools, we have outlined several potential data sets and tools that we can work in the system. So you can see some of them here with the USGS NHT, RSI, eHydro, NWIS, and HydroSWOT, and 3DEP, StreamStats, individual network, and regional curve data sets. So these are some of the probably major examples that we can work, but we are also open to suggestions from our partners, and we like to connect not just the large-scale federal data set, but also we are happy to probably work with some local partners and local organizations to work with some also specific or long-tail data sets as well. In terms of the tools, there are several tools that we identified that will potentially benefit our use cases. So these are some examples here, but we are open to collect more feedback from the community. So in the coming probably months, we will have some surveys for our data partners to collect more information about some of the ideas that we have and try to expand these data sets. In terms of the infrastructure here, so Venkatesh shared some of these slides, but this is mostly about the backend and design. So we will have a presentation layer that you can access through a web browser. It will be a mapping and a visualization system. It will be an interactive, rich user client, and this will connect to our database through our web service. The web service will be designed in a modern and standard structure where it allows us to consume in our system as well as share with our partners to integrate their own workflows. And visualization and mapping will be on a web-based environment, so you can access all the data in a geospatial mapping environment and run some analysis and visualizations directly on the web. And on the modeling side, we have several tools and analysis that we are planning to integrate to the system as well, to simplify some of the common workflows with the river morphology data sets. In terms of implementation, we already have our landing page up and running. So on the front end, there are several technologies we plan to use to implement the design, as well as we are using in Docker and some other container technologies to create a flexible API, both supporting a front end as well as the backend system. So the API will allow any partner to use these data sets in their own systems in real time. On the database level, we are focusing mostly on PostgreSQL with PostGIS libraries that allows us to run large-scale geospatial analysis on demand, on fly. And here's an example of the data exchange service. And you can see some of the features and data sets are already exposed to access. So you can see, you can post and read and update and change these features and capabilities directly through an API without using a separate system. And it's also standard modern API design that allows to use with existing API desktop clients like Postman and many other example systems. And just a quick example, this is on my last slide. So we will have a large-scale mapping system based on Google Maps or any other, maybe another mapping library, but it allows us to visualize the data both at the map scale with the features and objects, but also we will have maybe 3D visualizations of cross sections and other features, as well as dynamic interactive visualization of the raw data, as well as custom visualizations of observations like sedimentation and many other information could be visualized through these web-based systems. So it was just a quick overview and mostly the vision and plan for the next couple of years, but we are happy to collect more feedback from the community and our partners to shape the design and capabilities and support as much use cases as possible within the community. And that's all from my side. And I'll be happy to answer any questions if I have any minutes. But we will also have a discussion session in the last hour, so we'll have more time for questions for any of these components and presentations as well. Thank you.